This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. 2.5 Admins, episode 265. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. I thought it might be fun to install FreeBSD on my old Optiplex.
Wait. Not on a ThinkPad? Where's Joe?
Well, this thing's going to be a server, I thought, so I'm not going to be looking to do desktop stuff on it. Really, I just thought I'd set up a replication target. And it was actually pretty straightforward.
If you're not going any deeper into the system than just like, I want to be able to replicate my backups to this thing, well, there's not really a whole lot different between FreeBSD and Linux. I mean, they're both running OpenZFS. It's not even different code bases anymore the way it used to be when, FreeBSD had its own port from upstream, ZFS, and ZFS on Linux had its own port. It's a unified code base now. Yeah, stuff all works the same. If you've only ever used one Linux distribution, then you may have an idea of like, this is how hardware is configured, and, have a sudden, oh my God, panic when you get, confronted with the way FreeBSD does it. To be fair, if all you had experience with was that one Linux distribution, you would have the same panic on like low-level configurations when you go to a different distribution not in the same family. Like from Ubuntu to Debian, you're not going to see much difference. But you go from Ubuntu to, RHEL, or you go from Ubuntu to Arch, or you go from Ubuntu to Void, or, whatever, and you'd be like, oh my God, where do I even put my IP address? This is hard. If you already know, or familiar with, and can deal with like, learning the vagaries of a new distro from a different family in the Linux world, going to FreeBSD ain't really much different than that, honestly.
The installation is so bare bones, though. I had to install everything, like lsblk, wget, even sudo I had to install.
Well, to be fair, you're not usually expected to use sudo in the FreeBSD world. In the FreeBSD world, normally one uses su to become root, like the whole shell becomes root, and you just run your commands, and then you exit the su, once you're done being the super user. So adding sudo, yeah, you do need to do that because you're saying, I want to administer this FreeBSD machine like it's still one of my Linux machines. And it lets you do that. It's not hard. You just install sudo and poof, you can use sudo.
Yeah, it's one of the things that FreeBSD out of the box comes with 0 packages installed. And that was by design, separating what is the operating system from what is the software you installed on your operating system. But yeah, that is a big change for a lot of people. wget is not your normal downloading tool. wget is for mirroring websites. It's kind of weird that it became the default thing to download files. But in FreeBSD, there's a built-in tool called fetch that is what you would use to download, an ISO or a tarball or something.
Right, and is the syntax just the same then?
Yeah, it's fetch space the URL, and it will download the file.
Right.
Stop trying to make fetch happen, BSD. It's never going to happen.
Fetch is terrible. I install curl, but I don't install wget anymore. It's been a decade since I used wget, except for one time when I needed to scrape and mirror a website, because that's what wget is for.
Yeah, with the like recursive flags and stuff, yeah.
Before we move on from, how minimal FreeBSD is, I do want to make the point that it's not just that it's a good idea for a server distro to be minimal. This is not unique to FreeBSD. It's not like, oh, FreeBSD did this weird thing. Is it good or is it bad? It's just a server distro. If you install Ubuntu Server, it's almost as minimal as FreeBSD is. If you install Ubuntu Server and you select the minimal option, it is every single bit as stripped down as FreeBSD is.
Let me ask you about updates then. When I was reading various documentation, I found package upgrade-v, but I also found FreeBSD-update fetch and then FreeBSD-update install. Are they doing the same thing or what?
So on FreeBSD 14, no. FreeBSD-update updates the operating system. So that's the parts that were already there when you installed FreeBSD. And package upgrade just deals with the third-party applications you added after.
So I need to do both then?
Yes. And in particular, if you do package upgrade-v, it only upgrades applications that are known to be vulnerable. Whereas if you just run package upgrade, it'll upgrade everything to, if there's a newer version, it'll upgrade it right away. Whereas -v constrains what it updates just to things that have known CVEs and fixes.
Right. So you don't have an unattended upgrades equivalent, right? You just have to make your own cron job.
Well, so FreeBSD update, it has a special option called FreeBSD update cron that will sleep for a random amount of time before it does the update so that everybody doesn't hit the upgrade mirror at midnight and so on. But no, there's not really an unattended update, although the times that there are FreeBSD updates are a lot fewer as well, right? Like there will be a security advisory and an email will come out to you saying there's a new version. It happens, maybe once every 3 months or something. It's not like there's a new update to install every other week most of the time. Because the amount of stuff included in the operating system is so small, it's not vulnerable as often.
Sure, but you're pretending that the stuff in the base operating system is all that matters. And Apache doesn't have any fewer number of updates to apply under FreeBSD than it does under Linux. But your FreeBSD update cron won't even apply to that because it's not a part of the base system, but it is still mission critical.
That's why you need to do the package upgrade more frequently then, is what you're telling me.
Yes.
Right.
And you can't script it is also what you're telling us.
Well, no, you can. It's just you have to create the cron tab yourself.
Is it verifiably safe to run from cron?
Yes.
Because that's new. Back when I was a daily FreeBSD user, I was like, do not try to do this stuff automated. Like, that's not how we designed it.
Was package ng a thing yet, or was it still in beta back then? What version of FreeBSD did you stop at?
It's been a while. I think my last real true production use of FreeBSD was probably either 10 or 11. It's been a minute.
Right. Well, in 9, the package system was new.
This was not I gotcha. I was actually asking the question because, and it's an important question to ask because even over on the Linux side of things, like we need packages like unattended upgrades because like apt tells you every time, you use it, if it thinks it's being run non-interactively, it barfs out a warning like, I don't know what's going to happen if you use me non-interactively. I don't know when somebody has put in their package upgrade script an interactive thing that will ask you a question. I don't know if they error trapped it properly so that if you don't answer the question, what will happen? I don't know. It's risky. I wouldn't advise it.
Yep.
So knowing all that, I had to ask you the question, is it actually safe to just make a cron tab with package upgrade in it? Because it's not safe to do that with apt upgrade over on my side of things. You really need the unattended upgrades package.
So it is safe on FreeBSD now. Caveat to that, there are 2 different package repos on FreeBSD. The default one, which is called quarterly and only gets security updates and version updates only happen once every 3 months. That one will be safe to do that with. The one called latest that gets updated every 3 or 4 days might be a bit rockier.
And what if I just yes to the installer without fully reading it? What did I end up with?
The default is quarterly and you're fine.
Right.
Also, in FreeBSD 15 that's coming out later this year, it will also be possible to upgrade the operating system using the package tool. This is a feature that's been coming for a couple of years now called Package Base, where we manage the operating system files with the same package manager. So you'll be down to be able to just have one tool that updates both things instead of needing 2 different tools. But that will only apply to FreeBSD 15 and newer.
I also noticed, I am no systemd hater, but I did like that it was just old school service thing, start and restart. None of this systemctl nonsense.
Because FreeBSD uses sysctl to set settings throughout the system so much, my finger memory can't type systemctl. It types sysctl when I try to do it. Like I just start typing and my brain does the rest of the word and then it doesn't work and it confuses the hell out of me every time I have to use a Linux that has systemd.
We have sysctl on the Linux side too, by the way. That is the thing over here.
Yeah.
We just don't use it as extensively as FreeBSD does.
Right.
I don't understand why yes and no have to be in caps. Or do they?
Most of the shell scripts do have a thing to catch all of them, but yeah, that's for historical reasons.
Okay.
To be fair, those historical reasons were sometimes quite valid. You used to pretty frequently encounter things that would require all caps, yes, if you wanted it, because it was a dangerous freaking option. They wanted to make certain you had actually read and were paying attention, as opposed to just blindly going Y enter, Y enter, Y enter, Y enter until it stopped bothering you.
I also tried to type IP adder and it just errored us. Oh yeah, ifconfig, of course.
Although actually now that FreeBSD has native support for netlink, you can actually get the IP tool and use it to configure the network if you really wanted to.
Right.
But I don't.
Exactly. I'm so used to being able to use the real version of ifconfig that FreeBSD has to be able to create VLANs and link aggregations and so on. I can create a whole stack of those with 1 or 2 ifconfig commands and have it just work. And every time I have to try to set it up on Linux, I'm like editing multiple YAML files, and it's trying to apply things as soon as I hit save before I've actually told it I've edited the second file this depends on. And yeah, Linux and me don't get along very often.
Now, Alan, we throw around the F-bomb and, a few other profanities pretty frequently on this show, but don't ever say YAML again. This is a family show.
But all in all, I was surprised at how straightforward it was. Granted, it was a very specific, simple job that I wanted it to do, but even getting Tailscale running on it was easy, and just a lot of things that I didn't expect to be straightforward were. And I feel like as a FreeBSD noob, it's not as scary as I thought it was going to be. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Sam writes, making my way through Kirk McCusick's FreeBSD kernel internals video lecture series, I found a warning in his discussion of systat. Don't put too much faith in the value of %busy. It can only be a guess at how busy a hard drive is on account of the lies our storage tells us. What do you think about the lies our storage tells us?
Well, first of all, I want to take a little bit of issue with, crapping on %busy, because yes, it is only an approximation, but that is a really, really, really useful approximation. I have been using %busy as an indication of, when drives are likely to be failing and, to figure out where individual performance issues might lie in larger pool topology for many, many, many years. And honestly, it's never misled me. Is it entirely accurate? No, but this is the last place I'm going to complain about inaccuracy in a tool personally.
I think the thing people find confusing about it is the drive will say 100% busy sometimes at 100 IOPS, and other times say 100% busy at 800 IOPS. And it's well, which is 100% then? And then same for different throughput levels and so on. And it can be really confusing that %busy has no correlation to the IOPS or the throughput necessarily of the drive. It is just, does the drive seem like it has any time left to do extra work? Which is a very different thing than how many megabytes per second or how many IOPS per second the drive is actually doing.
But that's what makes %busy great, because it does just what it says on the tin. It's not tied directly to IOPS or directly to throughput. It doesn't matter which potential storage bottleneck you hit. If you hit a bottleneck and you pin a drive all the way dead busy, %busy is going to tell you that drive is completely busy. It's not going to miss it because, no, you didn't hit the IOPS bottleneck because you're working with very large block workloads. So it turns out you actually hit the throughput bottleneck, and you didn't even hit the throughput bottleneck of the drive. You actually hit the throughput bottleneck of the controller the drive is attached to. %busy doesn't care about any of that. If the drive is 100% busy, it's going to say it's 100% busy. And that's an issue. And if one drive says that when a whole bunch of other drives in an array that should all be being accessed in almost exactly the same pattern, if one is at 100% and all the rest of them are 38, you probably got a problem with that drive, and it's time to replace that drive.
Yeah. One of the other biggest lies storage tends to tell you is it lies about the sector size. Sometimes that's a feature, though. You'll see drives marketed with 512E, meaning emulated. So they will pretend that they do 512 byte sectors, even though natively they might actually be 4K. And that's because, older operating systems and certain software can't support a size other than 512 bytes.
Windows XP.
Yep. And, we've even seen certain versions of Microsoft's SQL Server can only work on drives that have 512 byte sectors because they're trying to keep their page size small and so on. They just didn't have native support for 4K, and eventually I think newer versions do, but it actually means that oftentimes in your hypervisor, you have to make sure the hypervisor emulates a drive with the small sector size in order for it to work.
Which is extra wild for Microsoft SQL Server, because Microsoft SQL Server defaults to a cluster size in the database of 64K, larger than the page sizes that you find in Postgres or MySQL.
Yep. And so some drives will report in some slightly roundabout way the actual physical sector size as well. And, ZFS and your file system and your operating system usually can tell that and align things so that they'll cooperate with the drive and not make the drive do as many unnecessary read, modify, writes, and so on.
Except when they lie in the firmware about that actual physical sector size, looking at you, Samsung, and your entire consumer line.
Yep. I've seen also SSDs that have like an actual 64K or 128K native sector size, and they emulate 4K. And that mostly works, but when ZFS tries to actually support that huge sector size, it can actually lead to a suboptimal configuration. We had a customer using smaller records for their VMDK files. As we talked about in a previous episode, you want to tune the ZFS that's storing your virtual machine's backing images with a reasonable sector size. But if you set the record size to less than the sector size of your drive, ZFS is going to have to waste the rest of that sector for each one. And suddenly you've written 500 gigabytes to your drive and your 1 terabyte SSD is full.
The lie that storage tells that makes me the angriest isn't really something I can pin on the storage itself. It's not something that originates from technical processes or code. It originates from marketing. In the dawn of the computer industry, everybody collectively decided that it would be a very convenient shorthand to refer to multiples of 2 to the 10th power, 1024, as kilo something, and then mega something, and then giga something, despite the fact that those prefixes already existed and already had a meaning. It wasn't multiples of 1024, it was multiples of 1000. This was basically fine as long as it was all just us engineers and nerds using this computer stuff, and we all knew what we meant, and it was great. But then eventually, money came in, as money always does, and the marketers realized, hey, you know what? If we can claim that hard drives are larger than they really are, if we use these metric prefixes properly, we'll tell everybody, hey, look at how many megabytes you're getting in this drive, but we're using proper metric megabytes, of which, there's about 10% more of them on the same actual capacity than the technically mebibytes, the multiples of 1024, that are what the operating systems are actually reporting for the capacity of the drive. And the reason the operating systems report that capacity is because it directly maps to those sector sizes, which again, we're talking about powers of 2, not powers of 10. And that was bad enough in the days of megabytes, but it compounds every time the drives get bigger. When your drives are in gigabytes, now it's not, a roughly 10% bump, it's a roughly 11%. Then you go to like 12 or 13 once you're into the terabyte era. And as a result, I have spent literally probably entire sleepless weeks of my life, if you put all the time for all the explaining and all the arguing and all the upset customers that think you screwed them over after you sell them a hard drive, that the operating system doesn't tell them the same number that the box did.
Yeah, my 16 terabyte drive is only showing 14.6. Well, you stole my storage.
Exactly. And trying to explain all this to people is just, again, I've literally spent weeks of my lifespan just having that argument with hundreds, if not thousands of people by now.
Yeah, and then especially when they tried to blame it on formatting back in the day. It's the formatting, because certain file systems would reserve a certain amount of space for the file allocation table or the MFT and so on. And while that's not untrue, it's not the main contributor to why the usable space is less than what it said on the box when you bought the hard drive.
What about smart data? There's lies in there.
Yeah, so obviously people forging the data and like resetting the data on used drives and so on is a whole different thing. But yeah, smart data is interesting because it's a standard that has no standard to it.
Yeah.
Every vendor is free to define the values and what they mean. So even if you're comparing just two different models of the same hard drive, it's not necessarily going to have the same counters. And the counters internally are just a number. And so it depends on the tool you're using, like SmartMon tools is the most common one on Linux and BSD. It has a database and tries to know, okay, for this model of drive, attribute number 138 meant this. I've seen that go completely wrong. On certain brands of SSDs, it misattributed one of the media wear-out indicators as the temperature. So you install the drive and the temperature reports as 100 and it keeps going down as the drive gets older. It's like, actually, that's definitely not the temperature. There's another attribute also labeled temperature. hey, how are there two different attributes labeled temperatures? Like, well, because every vendor gets to make up their own. And they don't have to be consistent between different models of drive even. And yeah, you can get all kinds of things where it turns out what the smart tool you're using to display the raw data has interpreted a certain value to mean might be wrong. And so, you can get temperature value that has a measurement in like millions, and it's actually the read error rate or something. And you get all these different things, and it is just very poorly specified, and it doesn't necessarily mean what you think it means.
I think it would be fair to say that the only actual specification in Smart is the specification of an extremely simple key value store.
Yeah.
That's where it ends. There's no further specification defined beyond that. Here's a very simple KVS. Here's how you write to it. Here's how you read from it. We're done defining Smart.
Yeah.
Yeah, why do I have to do maths of getting the LBAs written, find the sector size, do the maths on that? Why doesn't it just tell me how many terabytes have been written?
BFYTW.com.
Exactly.
The biggest part there is actually that the counters and the protocol for Smart are, only 32 or 64 bit. And so storing the number as the number of sectors or blocks instead of as the raw number of bytes means it takes less memory, and that it can store a bigger number before it rolls over back to zero.
Right.
And that's why I think on older Intel SSDs, there was a second counter that just measured it, and they told you in the name, the attribute name, it was just megabytes. And it didn't directly correlate to sectors and so on because you don't know what that megabyte was made up of and so on. But they tried to work around that problem by having a counter that was just the number of megabytes.
Yeah, honestly, I'd be pretty content with a counter that was in terabytes. I'm not sure when I really need write endurance calculated more finely than that.
Yeah, just like terabytes and maybe go down to one decimal place.
Well, it doesn't do decimals at all. So maybe what you want is gigabytes, I guess.
Yeah.
Because you won't get more than a couple million of those, even if you have petabytes of writes, right? And that way you get a number smooth enough that you could graph it and it wouldn't be very steppy. But yeah, the Smart is all vendor defined. So unless you're using the vendor's tool, you have to assume all the values are a best guess as to how you should interpret that number. The raw number itself is probably what the vendor meant it to be, but what that value means is probably not what you hope it means.
Well, what that value means is also what the vendor intended it to be is the problem there, because there's no standard for the actual data or what it actually measures. You're at the mercy of whatever tools the vendor feels like giving you, and they're only as accurate as the vendor feels like making them. And in this case, in my experience, that is not a whole lot. Where I went to great lengths to laud %busy despite its imperfections as an incredibly useful metric that is pretty much never really misleading in a real world way. Smart values are entirely the opposite because A, they're frequently not what they're supposed to be. They're frequently not what you think they are, and they're frequently just not useful at all. At this point in my career as a pretty senior sysadmin, I would say that I have probably seen maybe a couple of thousand drive failures. At the same point in my career, I have seen probably 10 or 15 well-indicated pending drive failures in Smart data.
Yeah, I was going to say, I think the biggest surprise I ever had was when Smart actually reported a drive as, quote, failing. It's like, this is the first time I've ever seen that. Also, the drive is still working, unlike every other failed hard drive where the Smart data says everything is fine, but you can't read or write from the drive.
Yeah, and what about old age? About to fail on a brand new drive? What's that about?
Well, the old age is the name of the column. It's the type of the counter. And it's saying that it's expected this counter will keep going up as the drive gets older.
Right.
And yeah, a lot of it is about interpretation.
Yeah. More importantly, it means you don't know what you're looking at, which is not an insult in any way. It's an accurate statement. And I also don't know what I'm looking at when I first look at the output of Smart Control A on any given drive. There's some Googling needed to make sure that I'm looking at what I think I'm looking at and that, it's properly represented in SmartMon tools, that the vendor wasn't lying about it, that it increments the way that I would think it increments, because none of those things are universally true. And I don't care how long you've been doing this, you have some sleuthing to do before you go relying on the output of Smart data.
Yeah, like when a customer sends us, hey, we think this drive's failing, here's the smart data. I'm like, can you send us the smart data from a couple of the other drives that are the same model but are not failing? So we can tell what's normal and what's not. It's like the read error rate looks high, but it might be normal for that type of drive. Or, this or the other thing. We had one with, Dell wouldn't believe the customer that the NVMe was failing. And they had the smart data and it was pretty clear, but there was another drive in an identical server where most of the same indicators, but it was working fine. And it was like, okay, we're comparing them. We see, okay, this is the one counter that's much different on the failing one than on the working one.
I really love it when you have a drive that suddenly starts throwing a couple of thousand checksum errors in ZFS and you look at the smart data, no read errors, none, not one.
Yep, the CRC was fine. Or also like, our monitor is like, hey, this one drive has had 5 relocated sectors. That's not 0. Maybe that's suspect. And then that drive continues to work fine for like 4 more years. Where another drive is like, oh, I have 1 relocated sector. And then you check again later, oh, I have 100 relocated sectors. And then it's like, and I'm dead.
Well, usually the reason behind what I was describing before, when you get thousands of checksum errors reported at the ZFS level, but your smart data says there were no read errors on the drive, there are a couple of potential causes for that. One being if the error is north of the drive. If you've got a dodgy cable, well, then the drive has no way of knowing that there was a problem because the problem wasn't in the drive, it was outside the drive. But I've seen that happen quite a lot where the drive was in fact the problem. Replacing the cable did nothing to resolve the issue. I had to replace the drive. And after replacing the drive, checksum errors stopped appearing. So how does this happen? And the answer to that is, unfortunately, many, if not most, in my experience, models of drive, they won't record a hardware read error if they read the same block 4 or 5 times before finally getting an answer that they like. So you can have a drive that is extremely slow and bulky because it is actually experiencing tons and tons of hardware read errors. But if it can average getting something that passes its weak CRC checksum on the 5th or 6th read before it's given up completely, it just doesn't log that in the smart data at all. It says, well, that's not an error. I eventually gave you something that passed the checksum. Well, the other thing about that is when you've got that happening over and over and over thousands of times a day, the odds that some of those are not going to pass the checksum because you finally got the right value, but simply because you got a value that still passes that relatively very weak checksum, that's when you start seeing ZFS detecting errors that the hardware does not. Because the hardware does a just barely sort of kind of enough checksum, whereas ZFS does a, no, we're not kidding, you have to fail a 1 in 2 to the 77th gamble in order for us to, report a false positive here.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send any questions or feedback. You can find me at joelrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.